Now in this video, we're going to answer the following question. A curve has equation y equal to x cubed minus 6x squared plus 9x. Find the maximum turning point. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. A stationary point on a curve is a point where the gradient is 0, meaning the tangent at that point is horizontal. A maximum stationary point is a stationary point where the curve reaches a local peak. Just before a maximum, the gradient is positive, and just after it, the gradient is negative. Answering this question is a 4-step process. First, we need to differentiate the equation twice, equating the first derivative to 0 and finding the x value of the stationary points, and a second time to find the type of each turning point, before substituting the value of x for the maximum point into the equation to find its corresponding y value, before stating the coordinates of that point. We've been given the equation y equal to x cubed minus 6x squared plus 9x. We need to differentiate this equation once to find the x value of its stationary points, and again to find the nature of those points. Differentiating using the power rule, one term at a time, x cubed differentiated is 3x squared, minus 6x squared differentiated is minus 12x, and 9x differentiated is 9. So, the first derivative, dy by dx, is equal to 3x squared minus 12x plus 9. Differentiating a second time, 3x squared differentiated is 6x, minus 12x differentiated is minus 12, and 9 becomes 0. So, the second derivative is equal to 6x minus 12. Now we can find the stationary points for this curve by setting dy by dx equal to 0 and solving for x. So, 3x squared minus 12x plus 9 is equal to 0. This is a quadratic that we can factorize into two brackets, but we can divide by 3 first because 3 is a factor of every term. So, x squared minus 4x plus 3 is equal to 0. 1 and 3 are a factor pair of 3, with a sum of 4. And taking into account the signs, that gives us x minus 1 in one bracket and x minus 3 in the second. By setting each bracket to 0, we can solve to find the values of x. If x minus 1 is equal to 0, then x is equal to 1. And if x minus 3 is equal to 0, then x is equal to 3. For more explanation and examples of factorizing and solving quadratic equations, search our channel for Factorizing a Quadratic. Using the second derivative, which is 6x minus 12, we can determine the nature of each point. If the second derivative is less than 0, the point is a maximum. And if it's greater than 0, the point is a minimum. Substituting the values of x we have found into 6x minus 12, first, if x is equal to 1, then 6 multiplied by 1 minus 12 is equal to minus 6. And if x is equal to 3, then 6 multiplied by 3 minus 12 is equal to 6. That means the turning point with an x-coordinate of 1 is a maximum point, and the turning point with an x-coordinate of 3 is a minimum point. The question asks us to find the coordinates of the maximum point. So substituting 1 for x into the equation gives us y equal to 1 cubed minus 6 multiplied by 1 squared plus 9 multiplied by 1, which is 1 minus 6 plus 9, which is equal to 4. If y is equal to 4 when x is equal to 1, the coordinates of the maximum point are 1, 4. As an extension to this question, why not try finding the point of inflection? So the coordinates of the maximum turning point and the answer to this question is 1, 4. Please follow us on Instagram, TikTok, and Threads for daily maths content.